Dear students, welcome to Elements of Mechanical Engineering. In my last video, I have discussed about the solar radiations and solar flat plate collector. So in this video, we will see how the solar pond technology will work. All right. So here this is also comes under solar energy, and so it is an example for renewable energy because as and when that the solar is available in this universe, so we can create this energy with the help of the sun's radiation. So on in this, what we have to supposed to do is we have to dug a pit. So this is a pit, solar pond. It's nothing but we are creating a pond. So by digging a pit from the ground level. All right. So from the ground level, when we after finishing that after digging the pit, so what we are supposed to do is we are going to put salt. Okay, then the ground level. That means beneath that, so there will be salt will be put inside, and then so there will be water will be poured completely, and then sun's radiation will come and fall. So let us see what are the different components that we come across here. So in this ground level, sun's radiation will come and fall on the top surface, and there will be a fresh water. And then if you go a little deeper, there is an intermediate or gradient zone which is in increasing salt water. And then if you go a little deeper, so there is a storage zone which is saturated salt water. So in this, hot water will be available or obtained, and this is covered by plastic lining, so that so there will not be any heat transfer throughout. So what we are going to do is we dump salt inside the rock salt inside the pit, and then we pour water, and that will be what you call differentiated between these three regions. One is surface zone, intermediate zone, and storage zone. So in this one side, so if you allow the cold water go inside, so this way the cold water will go inside, and since that salt will contain an enormous amount of energy, heat energy, so that cold water will be converted into hot water, and that hot water will be taken out. So this is how in the solar pond technology, how the what you call the heat will be created, or hot water will be created. Okay. So if you look at this, salinity gradient polar pond is integral collection of storage of solar energy, and we are making use of this sun's potential energy in this solar pond, and we take the sun's radiation and we allow that energy to be stored in the bottommost portion of the pit, and then the cold water will be sent inside, and that hot water will be coming out. So this is how we are going to what we call make use of the solar pond technology. And the next one is photovoltaic cell. So this is the photovoltaic cell, and this is also an example for the solar energy, because with the help of the sun's radiation we are going to what we call create the energy. Okay, so we'll see how the setup is arranged, and there will be negative electrons, and there will be positive electrons, and there will be electrical line which is wound, and there is a load which is nothing but you can call it as a bulb. You can fix one bulb over there, and so the on topmost portion it behaves as a junction between this negative electrode and positive electrode. So negative electrode is a non-reflecting shield, so this is called as n-type silicon, and beneath that there is a p-type silicon, and there is a positive electrode. So this is the arrangement, right? And now for sun's radiation will come and fall on the negative electrode, so it will absorb, and negative electrons will have holes, and in sun's radiation it will have photons. The photons come and fall on the electrons, which is a negative electrode, so both will combine together and dislodge the location. It will flow from one portion, one type of silicon, like n type of silicon to p type silicon, and that path will be like electrical line. and the flow of electrons is nothing but current. Call it as the flow of electrons. So what happens, the photons in the sunlight will come and fall on the electrons, and it gets charged, and then it will start flowing in the electrical wire, and then it will come back to the positive electrode. So it keeps on flowing. That flow of electrons is nothing but current. And then when current passes, if you keep one bulb in between, so that bulb will start glowing. So that is nothing but electrical energy. How we are going to get that is from sun's energy. So with the help of photovoltaic cell. So this also comes under solar energy, and this is called as a renewable energy, because until unless the sun's energy is available in the atmosphere, so we can make use of this energies. So where and all the applications, I'll let you know. So where and all it is used, that electrical signals like train signals, and batteries, and then solar cars. So there are various plenty of areas these photovoltaic cells are used. All right. So let us see in detail. So solar energy can be directly converted to electrical energy by means of photovoltaic effect. That is what we are talking about. That photovoltaic cell, which will have that photovoltaic effect, and this photovoltaic effect is defined as the generation of electromotive force, which is nothing but EMF, as a result of the absorption of ionizing radiation. Devices which convert sunlight to electricity are known as solar cells or photovoltaic cells. Solar cells are semiconductors commonly used are barriers type iron selenium cells. So here we need to absorb, we need to understand here there are two types of cells are there. One is N type and P type. Same, if you take any semiconductors, and if you dope with boron and that kind of material, so it will become N type. And then the same type of semiconductors, if you dope with beryllium, that type of phosphorus, then it will become P type. So if you take any semiconductors and dope with different materials, so it will become N type material and P type material. So that is how. So you will prepare what you call make that two different N type and P type silicon cells, and so both will be and there will be a line partition which separates the negative cells and positive cells. So that is nothing but the junction. All right. So the various applications these photovoltaic cells are used, as I have told you. This it's a very simple in arrangement, and it takes the energy from sun's energy, right? So when the photons come and fall on the electrons, and the electron absorbs that photon, and both will combine each other, and then it starts moving, flowing from one place to another place, that is N type silicon to and P type silicon. So during this journey, that flow of electron is nothing but the current, which if you put some vertical load in between, so you'll get the current. So that is how we are going to make use of this photovoltaic cell. So here in this two things we have seen. So one is a solar pond technology. So this is an example for what you call solar energy. So solar energy can be classified into three types. So one is solar thermal energy, and next one is electrical energy, and then thermal, electrical, and next one is solar pond technologies. So they can be classified into three different types. So first one already we have discussed in the previous one, solar flat plate collector. All right. So and next one is solar pond technology, and then so we have seen the photovoltaic cell. So sun's energy, thermal, and electrical, and chemical. So this comes under chemical energy, and solar flat plate collector comes under thermal energy, because it heat is generated. So this is chemical energy with the help of this sand, and salt is mixed with water, so this comes onto chemical energy. And with the help of this solar energy, the power or current is generated, that is why it is called as electrical energy. So finally we can say that solar energy can be classified into three different types. One is thermal energy, next one is electrical energy, and next one is chemical energy. Okay, thank you for watching this video.